so let's go ahead and try it again. Now it says there's space, right?
Yes.
All right, good. So find me the incremental internal rate of return going from asset, which one do you want to do? B to D. Incremental internal rate of return going from asset B to D. B to D. Incremental internal rate of return going from assets B to D. That's what we're looking for as the next kind of quiz question. And now I'll take it to you because I'm going to go talk to people. And we'll see what people are going to do. What do you got going on here?
I have no idea what I'm doing.
Know what you're doing yet?
Nope.
How do you guys doing? Incremental internal rate of return, B to D?
I didn't understand this.
I
have no idea. I have no idea.
Uh-oh. There's no idea what the incremental... Who knows what an incremental internal rate of return is? Raise your hand. We've got one guy.
Right.
All right. He watched the video. Perfect. He's actually doing really good here. You guys should see this. He's doing great.
I have no idea. I can't do math.
Yeah, you're not doing it right. Nice look. Very bad. Okay, so clearly that one didn't work out. So let's try this again. There we go. It's yours again. The whole thing, once it strains together, is going to look like what? Screwed up Cloverfield,
Blair Witch Project.
What was the latest one that was basically handheld shaky cam? The Last Exorcism was another one? Was it another one?
Paranormal Activity.
Yeah, that one I haven't seen.
It makes me sick. Watch people videos.
There's worse. I'll tell you a story about my father after we get this over. Okay, so what you're doing here is literally taking every element of D and subtracting from it every element of A. So you see where it says D less A right there? B. Is that what I said? B. Oh yeah, that works. B. So here's time period 0, here's time period 1. Time period 0, D is 30. And you're subtracting from it time period 0 of B, which is 20. And that gives you what? 10. There you go. Yeah. Wait a minute. Did we do B, D? I wanted AC. I wanted AC. My mistake. Oh, did that change anything for you guys? AC? No, OC less A. What? Minus 30, minus 20, minus 20. All right, what's minus 30 minus a minus 20? Thank God, that would be about right. All right, now, and then what you do is you take every element of C again, which is 34, and you subtract from it the element of A, which is 21. What's 34 less 21? 13, right? Yeah. Okay. So what you're doing is you're taking the difference between the two assets, and you see, basically the difference says that if you pay an extra $10, you'll get an extra $13. So what is the internal rate of return of the difference between these two series? So you can calculate this internal rate of return, which you have is the incremental internal rate of return. So, what do you think it is? 30%. Yeah, you can do that one in your head, can't you? 30%. Now, please note, the incremental internal rate of return is 30%. What's the difference between these two rates of return? Do you think there should be a relationship between these two? No. No, don't try to make one. Okay? There is no relationship between those two. The incremental internal rate of return is not equal to the difference of the internal rates of return. So what you got to remember, keep this guy in your head, is that the internal rate of return of the difference between two series is not equal to the internal rate of return of the series and the internal rate of return of the series. It's not supposed to work that way. Keep that as does not work. Okay? And that'll be the last of this little calculation scheme that we'll be working with, because what I want to do right now is get you into a incremental internal rate of return problem.
Can you remind us of what the incremental internal rate of return tells us, guys?
It's going to tell you whether you should upgrade from one asset to another.
Is it an exclusive choice?
Essentially what the procedure does, and the procedure is actually outlined fairly well in the wiki. What you're supposed to do is, given a whole bunch of assumptions, assumption number one is that you're actually dealing with all assets here. Okay? All things which are investments, because once you start mixing in loans, bad things happen to you. But what you're supposed to do first is first eliminate all the investments there that have internal rates of return that are less than the minimum acceptable rate of return. And that what you're looking for is exclusive choice. You're trying to find the best. That if you wouldn't pick it, if you could get more than that, you shouldn't be in the list. So you trim things out of the list. Then what you're supposed to do is order it from lowest initial investment to highest. And again, for a lot of investments, that's complicated. But I will usually give you things that only have an investment in time period 0, so it's fairly clear what's going on. And once you've got those things ordered, what you do is they're essentially doing it's a sort. You're having a bunch of tournaments. So what you do is you say, here's my best candidate, so you take the first one. And you say, who is the challenger? You grab the next one on the list, and you go, which of these two is better? And you weigh them, and if the original one is better, you throw this one away, and you go, you still won. And you grab the next one off the list, and you weigh these two, and if this one loses, you throw it away, and this is your new best candidate. And then you grab another one. And you keep on making these pairwise comparisons, these tournaments, until you have one left, and that one's the best.
Do you have to do that in order of descending investments?
Unless you want to keep track of which upgrade is a loan and which upgrade isn't, and that's why you want to do the ascending thing. Otherwise, your brain will crack. So, we good with this one then? So let's create a bizarre set of investments. So let's give you investments A, B, C, D, and E. We good with that? Assets A, B, C, D, and E are already ordered in terms of lowest initial investment to highest initial investment. So everyone's clear on it? And these things are all going to be investments. None of these things is going to be a loan. Now, what I want to know is, and what I mean by that is, I want you to go ahead and make up internal rates of return for these assets for me. So yell out numbers.
17.
17.
21.
21. I heard it 10. Next.
88.
23 and 88. Oh, sorry. I'm not going to use the 88 on this one. I'm going to use 8. I like that idea. Okay, so we got a bunch of these guys. And later on, we'll figure out what internal rates of return that we want to use. Now, what we have to do is form like this giant matrix of pairwise comparisons that you can have. So effectively what we're going to do is we're going to see how to go from A to B. Sorry. How to go from A to C, how to go from A to D, how to go from A to E. And so that's each of the upgrades that is possible right there. Remember, you can go A to B, A to C, A to D, A to E. That's what each of these represent. Then what we're going to do is try to go from B to C, B to D, B to E. And so it's...
Isn't there a shorter way to do this?
Matrices. Believe it or not, yes it is. It's just the lower triangle you want.
So how are...
Wait a minute, you screwed me up real fast. Give me a second. D, D, E, B. Go ahead.
How are A through E ordered again?
A through E are ordered in terms of lowest initial investment to highest initial investment. So it already satisfies your sorting. And I think the algorithm is like step 1 or step 0, something along those lines. Which is it? Did anyone look at that part?
It is.
Okay. And then we'll do the next set over here, which is go from C to D and C to E. And so it is E and E. And then the last one is to see if you should upgrade from E to D. And so we'll have E to D. And if you want to think about it as a matrix, it's just a lower triangle of that little difference matrix. So what we're going to do is we're going to create incremental internal rates of return for each of these. In real life, these are computed. Okay? So you can think about it as someone has the job of, and again, think, crank calculator that only does the addition, sitting back there with like log tables and things like that. Perhaps a slide rule could have been involved. Okay, so we're talking about a time when computation was relatively expensive, but the decision-making capacity of the brain was considered to be relatively cheap compared to the computation. And we kind of flip-flop that a little bit to a certain extent. And so what we're going to do here is show you the result of those computations, which are going to be just numbers that you're going to make up. In real life, you calculate those. So start yelling out some numbers for me. Try to make some of them below 10 for me, please, because you guys have this preference. 2. Keep going. 7? Yeah, keep going. Not all of them. 3. And what was the other one? 14. 11. 22. Keep going. 16. 34. 8.
27.
27. So we have now generated enough random numbers. Again, we're just making it so that we have an example to work through. This is probably not going to make any sense as an actual solution, okay? We're just trying to make it so we get through the algorithm. So we've got enough numbers through there. So let's go ahead and try to find what our best choice is for an interest rate. And this is the way that these were intended to be used. Again, you make one set of computations, and in order to find the best choice, given an interest rate, a minimum acceptable rate of return, you just follow an algorithm and you get there. So it allows you to do things like, oh, what if our loan is 12%? What's the best choice? What if our loan is 18%? What's the best choice? And you follow your way through the algorithm in order to find out what the best choice is. So one set of computation gets you many different sets of answers. Now, pick an interest rate. Who wants an interest rate first? Pick one. 7. So 7 will be the blue numbers. Now, here's where the pairwise comparisons work. How many of you have actually gone through this algorithm? Actually, you tried it once. Raise your hand. Okay, please go ahead and show that nobody raised their hand. Raise your hand if you've run through the algorithm once. Which algorithm? This one, that one. Exclusive choice algorithm. So that would be nobody, right? I'm putting this on the choice test. See how this one works. Anyway, we'll see. That's it. I'm putting one of these up. Alright, so what you do is you start with, this will clearly be not part of your quiz, so just go ahead and bring it down here, because we're kind of done with that. So go ahead and put it in there. Or should we put it in? Well, we're going to still keep working on it, but since nobody raised their hand as having tried it out, it seems rather pointless. I'll just kind of go in there. And we got a couple of minutes. Anyway, while you're turning it in, let's go ahead and start off the algorithm with our first best candidate. And you always start with a small one there. So A is our best candidate on this one right now. Now, are there any assets that have internal rates of return less than their minimum acceptable 7?
Yes.